Hello everyone. In this video, we will simplify the following expression. We have cosine 10 degrees plus cosine 50 degrees plus cosine 70 degrees plus cosine 110 degrees all over cosine 20 degrees raised to the power of 8. Obviously, we cannot directly simplify the expression in its current form because the angles here are not multiples of 30 or 45. Okay. But what we can do first is convert this into an equivalent expression containing angles which are multiples of 30 or 45. Now let's look for an identity or trigonometric identity that can help us convert this expression into its equivalent one. So how can we do that? Usually my approach to this type of problem is to get the sum or difference of the angles given and see if there is a pattern or a clue that can help us identify such an identity. For example, if we pair up 50 degrees and 10 degrees and add, the result is 60 degrees, which is a multiple of 30. Now, if we subtract, the result is 40 degrees, which is a multiple of 20, which is good because um, in the given we have here cosine 20 degrees. Okay, so there is a great chance that we can actually cancel cosine 20 degrees if we are able to, or we will be able to get cosine 40 degrees on top or in the numerator, or reduce cosine 40 degrees into cosine 20 degrees. Okay. um Now what if we pair up 110 and 70? So we have 110 degrees plus 70 degrees. So that's 180 degrees, multiple of 30. Now if we subtract, the result is 40, again a multiple of 20. Okay, so what does this tell us? This actually suggests that we must look for an identity that can reduce this one into an equivalent expression containing angles which are multiples of 30 or um, multiples of 20. Okay, just like 40 degrees. Okay, and the identity that I am thinking right now is the sum to product identity cosine x plus cosine y equals 2 times cosine x plus y over 2 times cosine x minus y over 2. Okay, now let's apply this identity to cosine 50 degrees plus cosine 10 degrees and to cosine 110 degrees and plus cosine 70 degrees. Okay, so let's have the first pair. We have cosine. So I'll write first 50 degrees. Cosine 50 degrees plus cosine 10 degrees equals 2 times the cosine. Okay, so I'll just add directly the angles. We have 50 plus 10, that's 60 divided by 2, 30 degrees. So this is 30 degrees. So I'll just enclose this one with parentheses just to avoid confusion. And then times cosine um, x minus y. So that's 50 minus 10 degrees. That's 40 divided by 2, that is 20 degrees. So as predicted, the cosine 20 degrees uh, comes out. Okay, so there's a great chance that we can cancel the cosine 20 degrees later on. Okay, now we can actually simplify this one directly. We know that cosine 30 degrees is square root of 3 over 2. Okay, and so if you multiply that to 2, the 2 will cancel out, and so what we have is square root of 3 times the cosine of 20 degrees. Okay, another the other pair, we have cosine 110 degrees plus the cosine of 70 degrees. That's equal to 2 times cosine. Okay, so 110 plus 70, that's 180 divided by 2, that's 90. So 90 degrees times cosine of 110 minus 70 over 2, that is um, 20 degrees. Okay, next. We know that cosine 90 degrees is 0, so the entire thing is 0, right? 2 times 0 times cosine 20 degrees, that is 0. Okay, so we can now replace some parts or components of the given expression on top. So if cosine 50 degrees plus cosine 10 degrees is equal to square root of 3 times cosine 20 degrees, then our given expression, so I'll just write it here at the bottom. So our given expression becomes square root of 3 times cosine 20 degrees plus 0 divided by cosine 20 degrees. Okay, then raised to 8. Now we can cancel cosine 20 degrees. Okay, so cancel. So what remains is square root of 3 raised to 8. Okay, take note that this is the same as 3 raised to 1 half raised to 8. So we actually have 3 raised to 4, which is equal to 81. Okay, so the value of this entire expression is 81, and this is our final answer.